Hello friends, we are going to study another important concept or tool in this video named QFD, that is Quality Function Deployment. QFD was first developed in Japan by Yuji Akawa in the late 1960s while working for Mitsubishi Shipyard. It was later adopted by other companies including Toyota and its supply chain. In the early 1980s, QFD was introduced in the United States mainly by the big three automotive companies and a few electronics manufacturers. Acceptance and growth of the use of QFD in the US was initially rather slow, but has since gained popularity and is currently being used in manufacturing, healthcare, and service organizations. In the world of business and industry, every organization has customers. When we are working to determine what we need to accomplish to satisfy or even delight our customers, then the tool of choice is Quality Function Deployment or QFD. Quality professionals refer to QFD by many names, including matrix product planning, decision matrices, and customer-driven engineering. I am going to explain this tool with various terms in it and detailed procedure to use this tool by example. So let's begin. Quality Function Deployment, that is QFD. QFD is a focused methodology for carefully listening to the voice of customer and then effectively responding to those needs and expectations. Quality function deployment is a process and set of tools used to effectively define customer requirements and convert them into detailed engineering specifications and plans to produce the products that fulfill those requirements. QFD is used to translate customer requirements or VOC into measurable design targets and drive them from the assembly level down through the sub-assembly, component, and production process levels. QFD methodology provides a defined set of matrices utilized to facilitate this progression. Why to implement QFD? Effective communication is one of the most important and impactful aspects of any organization's success. QFD methodology effectively communicates customer needs to multiple business operations throughout the organization, including design, quality, manufacturing, production, marketing, and sales. This effective communication of voice of the customer allows the entire organization to work together and produce product with high level of customer perceived value. There are several additional benefits to using quality function deployment. 1. Customer focus. QFD methodology places the importance on the wants and need of the customer, not on what the company may believe the customer wants. The voice of the customer is translated into technical design specifications. During the QFD process, design specifications are driven down from machine level to system, subsystem, and component level requirements. Finally, the design specifications are controlled throughout the production and throughout the assembly processes to assure the customer needs are met. 2. VOC competitor analysis. The QFD tool allows for direct comparison of how your design or product stacks up to the competitor in meeting the VOC. This quick analysis can be beneficial in making design decisions that could place you ahead of the pack. 3. Shorter development time and lower costs. QFD reduces the likelihood late design changes by focusing on product features and improvements based on customer requirements. Effective QFD methodology prevents valuable project time and resources from being wasted on development of non-value added features or functions. And 4. Structure and documentation. QFD provides a structured method and tools for recording decisions made and lessons learned during the product development process. This knowledge base can be served as a historical record that can be utilized to aid future projects. Companies must bring new and improved products to market that meet the customer actual wants and needs while reducing the development time. QFD methodology is for organizations committed to listening to the voice of customer and meeting their needs. How to implement QFD? The quality function deployment methodology is a four-phase process that encompasses activities throughout the product development cycle. A series of matrices are utilized at each phase to translate the voice of customer to design requirements for each system, subsystem, and component. The four phases of QFD are: 1. Product definition. The product definition phase begins with the collection of VOC and translating the customer wants and needs into product specifications. It may also involve a competitive analysis to evaluate how effectively the competitor's product fulfills the customer wants and needs. The initial design concept is based on the particular product performance requirements and specifications. 2. Product development. During the product development phase, the critical parts and assemblies are identified. The critical product characteristics are cascaded down and translated to the critical part and assembly specifications. The functional requirement or specifications are then defined for each functional level. 3. Process development. During the process development phase, the manufacturing and assembly processes are designed based on product and component specifications. The process flow is developed and the critical process characteristics are identified. And 4. Process quality control. Prior to production launch, the QFD process identifies critical part and process characteristics. Process parameters are determined and appropriate process controls are developed and implemented. In addition, any inspection and test specifications are developed. Full production begins upon completion of process capability studies during the pilot build. Effective use of QFD requires team participation and discipline inherent in the practice of QFD, which has proven to be an excellent team building experience. Now let's see Level 1 QFD. The House of Quality is an effective tool used to translate the customer wants and needs into product or service design characteristics utilizing a relationship matrix. It is usually the first matrix used in the QFD process. The House of Quality demonstrates the relationship between the customer wants or what and the design parameters or how. The matrix is a data intensive and allows the team to capture a large amount of information in one place. The matrix earned the name House of Quality due to its structure resembling that of a house. A cross-functional team having thorough knowledge of the product, the voice of the customer, and the company's capabilities should complete the matrix. The different sections of the matrix and a brief description of each are listed below. Let's understand QFD tool with practical example of pressure cooker. What? This is usually the first section to be completed. This column is where the VOC or the wants and needs of the customer are listed. There are various tools and techniques to collect the data effectively. If you want to learn that, you can visit to related video by clicking on this card. In an example of pressure cooker, it will be like cook fast, alarm when cooking complete, safe to cook, etc. etc. Importance factor. The team should rate each of the functions based on their level of importance to the customer. In many cases, a scale of 1 to 5 is used, with 5 representing the highest level of importance. In this example of pressure cooker, cook fast will be having an importance of 5, easy to use will be of 4, and durability will be of 3. How or selling contains the design features and technical requirements the product will need to align with the VOC. In case of our example, it will be cooking pressure, sealing, shape, size, thermal conductivity, strength, etc. etc. Body or main room. Within the main body or room of the House of Quality, the how are ranked according to their correlation of fulfilling each of the what. The ranking system used is a set of symbols indicating either a strong, moderate, or a weak correlation. A blank box would represent no correlation or influence on meeting the what. Each of the symbols represents a numerical value of 0, 1, 3, or 9. Let's do this for customer requirement of cook fast in an example of pressure cooker. The cook fast is having a very strong correlation with cooking pressure and is represented by 9. Similarly, the correlation between cook fast with shape of cooker is moderate and is represented by 3. There is no correlation between cook fast and weight of the cooker, and therefore it is left blank or represented by 0. Roof. This matrix is used to indicate how the design requirements interact with each other. The interrelationships are ratings that range from a strong positive interaction, double positive, to a strong negative interaction, double negative, with a blank box indicating no interrelationship. In case of our example, cooking pressure and sealing are having a very strong negative interaction, whereas cooking pressure and strength of the cooker are having a very strong positive interaction. Competitor comparison. This section visualizes a comparison of the competitor product in regards to fulfilling the what. In many cases, a scale of 1 to 5 is used, with 5 representing the highest level of customer satisfaction. This section should be completed using direct feedback from the customer surveys or other means of data collection. In an example of pressure cooker, we need to do the comparison of our product for each customer requirement with competitors on the scale of 1 to 5. For easy to use, our product is having a very good customer satisfaction and indicated by 4. It is comparable with competitor A and superior over competitor B. Relative importance. This section contains the result of calculating the total of sum of each column when multiplied by the importance factor. The numerical values are represented as discrete numbers or the percentage of total. The data is useful for ranking each of the how and determining where to allocate the most resources. In our example, an importance of cooking pressure is calculated by making sum of multiplication between importance of each customer requirement with its correlation with cooking pressure, that is 190. The relative importance of cooking pressure is calculated by dividing importance of cooking pressure by sum of the importance of all technical requirements, that is equal to 190 divided by 999 into 100, which is equal to 19.0. And the last part is lower level or foundation. This section lists more specific target values for technical specifications relating to how used to satisfy VOC. Upon completion of the house of quality, the technical requirements derived from the VOC can then be deployed to the appropriate teams within the organization and populated into the level 2 QFDs for more detailed analysis. This is the first step in driving the VOC throughout the product or process design process. Due to time constraint, we will see level 2 and next level of QFD in the next video. For references, in addition to my knowledge and experience, I have taken some part of this tool from Quality One site and IOQR site to make it more useful. Quality One is really having an in-depth explanation of the subject. I have mentioned the link of this topic in description. Now to end, share this video in your entire group to improve their life at professional level. Add your valuable comments and suggestions regarding it. I will be sharing such an important concepts in Lean and Six Sigma usually once in 2 weeks. If you don't want to miss such useful information on my channel, then click on the bell icon after subscription and select an option of Get All Notifications. And finally, thank you for watching.